Hello, and obviously now there is a lot of excitement because you now understand that some aspects that concern disease modeling are just brushed underneath the assumptions. And obviously, modifications, so there is this word modifications of the SIR model is one part of research that has been overly exhausted, as was said by Howard in his paper. So there are so many other extensions of SIR. Some people came up with SEIR, so SEIR, we've got SE IVR. There are so many ways where you look at this as susceptible, then the exposed, then the infected, the recovered. Some look at the vaccinated themselves. So there are so many angles through which this SIR model was approached and extended and expanded. But we are focusing on the basic model itself. So, what is the model? Well, we are talking about something that is changing with respect to time. We are talking about the group of susceptibles that is changing as time changes. How is the population of susceptibles changing as time is changing? The population of infected, how is it changing as time is also changing? How is the population of the recovered changing as also time is changing? And again, remember, I'm using recovered, but in our paper by Howard, it was actually removed. So, the model itself is like this. What do we have here? We are simply saying, look, the rate at which the susceptible population changes with respect to time is given by, so you can see that the susceptible population, it starts at this level, right? But with time, because there are no births, maybe it becomes half, and with time, it becomes almost one third until we don't have susceptibles anymore. So what is happening to the susceptibles is just, it's going down, right? It's going down. That is what is happening, and that is the meaning of the negative sign that we have got there. So if it is positive, then it means we are adding. It's negative, we are going down. It's positive again, we are adding to the class or the compartment that we are discussing. So in other words, we are removing from the susceptible. And what are we removing? We are simply saying that when the susceptible meet the infected, then they become infected at this particular rate, and we remove those people from being susceptible, but we add them to the infected population, because the infected population is gaining, but the susceptible population is losing. That is what is going on. And once you are infected, you are going to recover, and the rate of recovery is nu or V. It's nu there, right? Nu like that. So what is taking place there? Let me just call it V so that it's easier for everybody else. All right. So we are saying that people are recovering. They were in this infected class. They had the disease, but they are running away from the disease at this particular rate, and they are becoming recovered. So the recovered class is receiving, but the infected class is losing. So that is what is going on there. So let's talk about what we have got here a little bit. One of the things that you are going to do or to see, or actually you have to know, is the issue of units. All right? You need to know that we are talking about this beta here. All right, it's called beta. And what beta actually represents, according to what we have pointed out earlier on, because it's supposed to be very, very clear, it is the transmission rate, the average number of contacts that we get. So let me just give it to you here so that you can actually have a clear, precise definition. All right, let me just put it on a new page here, like this. Yes. So that is beta. So if we look at this particular definition, right, it is the transmission rate, yes, average number of contacts per person per time multiplied by the probability of disease transmission in a contact between susceptible and infectious. That's where the SI is, right? So we have got to take note of the following. We need to put into consideration that our units, because we are having people here over time, when we have got ds dt, the units are time and these are people, so these are people per time. All right, so we need to be able to balance those facts. They need to balance. So in other words, if you look at this is people, this is people, in other words, you've got people squared. If you want to look at it from that perspective, you've got people squared. So in other words, it means that the units of beta are supposed to, number one, include time, so per time, like that. And also there must be some people down there so that those people will cancel there, so that we now remain with people per time. So we've got people there, and then those people will cancel out with one people there, and then we remain with people per time. All right. So if you want to understand this definition that we've got there, you've got per time, which is per time that we've got, average number of contacts per person, so we've got people, so we've got people per time multiplied by the probability. The probability is dimensionless, it is unitless, right? So maybe the probability, let's call it alpha, all right? And then contacts between susceptible and infectious, but here we've got average number of contacts per person per time. So we've got per person per time, average number of contacts per person per time. So PT is actually in the denominator there, and we've got people squared, like p squared, and then this p will cancel with 1p there, and then we'll remain with p over t, and that will now make it possible for us to have our people per time units. So you must and you should be able to check all these units according to that criteria. Okay, so here the units also are supposed to be people per time, so we must have people per time. So people, the infected people per unit time. So the units of V here, which is new, is per unit time. And if we look now, they say D is equals to 1 over V. But what is D? It is the duration, it is the time of infection. So, but V is per unit time, so we've got 1 over time, which gives us time. That's why D is the duration of infection. So you need to be very, very careful when dealing with this model. You understand, number one, that whatever has been removed there, because it is infected, it comes down there. It is removed because it is recovered, it comes down there. That's what we have at this particular point in time. This is the model. It's a it's a system of nonlinear differential equations, 3 of them, And as you can see that we've got S, we've got I, we've got R, here we've got I, but we are talking about R. Here we are saying the rate is influenced by S and I, and here the rate is simply influenced by interaction of S and I as well. So these are the things that you need to understand so that we can proceed with further analysis.